Hello and welcome. My name is Del, and today I will be coding the bursting projectile feature into my game, as you can see in the preview on the left side. First, I'd like to mention that all of this code is available on GitHub, and I'll leave the link in the description below if you would like to check it out. Feel free to do so. And without further ado, I'll jump right into it. All of the necessary logic can go right here in the update projectile function, which is dedicated to handling projectile-specific logic. The logic for collision and physics is handled in other functions. This function acts on all existing projectiles. This will make more sense to you if you're familiar with the Entity Component System architecture, which is also known as ECS for short. And this is part of my new ECS framework project. The function accepts an entity ID and a projectile system node object, which contains four properties: death time, which is the in-game time at which the particle expires; position, which is a 2D vector representing the projectile's in-game position; and size. And lastly, the generation, which is best understood if you think about a family tree. The first particle will be of the first generation, and any particle that comes after that will be of the second generation, and so on. It basically is a variable that keeps track of how far down the chain the particle is. Currently, the code in this function will destroy the projectile when the in-game time reaches or exceeds the projectile's death time. And this is where we want to add the logic. As soon as the projectile expires and gets destroyed, we'll want to spawn many small particles that emerge where the particle expired, and they shoot outward at a high speed, moving out radially in all directions. And in order to do that, we can go through all of the angles from 0 to 360 degrees or from 0 to 2 pi in radians. And then we can go ahead and use trigonometric functions in order to figure out the velocity components. We'll begin with a for loop that goes from 0 to 2 pi to go through all the angles with increments of 1/6. Then we want to get the x and y components of velocity based on this angle, and we can simply do that with trigonometric functions, sine and cosine of the angle. Now we'll use the position of the expiring bullet and the velocity components in order to spawn the smaller bullets at this particular angle. Then we're going to make an edge case that is based on the size, so that if the bullet is smaller than a certain size, it will not fragment into smaller bullets. And let's see what that looks like in game. And there we go. I'm going to explode one more time. So that's pretty much what we wanted, but it's too uniform for an explosion. We're going to want to add some randomness in there, and it's only exploding into 6 points. I want to increase that to 9. To add randomness, we're going to multiply both velocity components by a random factor. The random factor will be 50% plus 65% times math at random. This will ensure that the random factor will be anywhere between 50% and 115%. And I made a Desmos calculator that visualizes this approach using 250 pairs of random values. I'll leave the link in the description below if you'd like to check that out. Let's see what that looks like in game. And voila, that's exactly what we wanted. The particles are fragmenting to the point where they're very, very small. So instead of relying on the particle size to end the chain of explosions, we'll use the particle generation property to end the chain of explosions after just one round, regardless of the size of the projectile. I hope you enjoyed the video. If you have any ideas, please do leave them down in the comments, and I'll see you next time.